So our next lecture is on speed and velocity. So these terms, speed and velocity, you might think they're interchangeable, but they do have different and distinct meanings in physics. Speed is distance traveled per time, and it's a scalar quantity, whereas velocity is displacement per time, and it's a vector quantity. So that is the difference. When we're talking about speed and velocity and outside of physics, they're often interchangeable, but it's important to kind of know that distinction here. This slide here says objects seldom move at one speed or velocity. They speed up, slow down, and change directions. Thus, it's good to talk about the average speed and the average velocity. So when you're driving, you might be driving at the speed limit is 50 kilometers per hour, but you're not always driving at 50 kilometers per hour. You speed up, you slow down. In your average distance might be, if you traveled for an hour, you might travel 50 kilometers, but that might not necessarily be how fast you're moving because you fall out stopping. So you might actually, when you look at your average speed traveled, it might be closer to 30 kilometers per hour, depending on how traffic was. So how do you find the average? There is a simple formula for average speed. It is the difference, or the delta d, which is the distance, so the change in the distance divided by the change in time. That is our average speed. That triangle you see on the side, the dVt triangle, that triangle can be used to help develop an equation for average speed, or to find out your distance, or to find out your time. So v equals d over t. D could be written as v times t, and t, the time, could be d over v. Let's look at a sample problem. Here it says a dog runs in a straight line, and the distance that the dog travels is 43 meters, and the dog travels this distance in 28 seconds. So v is d over t. So my distance traveled by the dog is 43 meters over 28 seconds. And let's throw up my calculator here. If I calculate that, that would be 43 divided by 28. I end up with 1.53. That works out to 1.5 meters per second. And if you're wondering about significant digits, you might not have heard of that term yet. We are going to talk about that a little bit later. At first, I want you to understand how to do some problems in the course first, and then we'll talk about significant digits a bit later in the course. Next problem, we have a baseball rolls along a flat parking lot, and this baseball travels at a constant speed of 3.8 meters per second. How far will the ball roll in 15 seconds? So now we have a baseball, so we are trying to find the distance traveled. Distance traveled would be equal to the velocity times the time, and the velocity is 3.8. The time is 15. So let's pull up the calculator again. 3.8 times 15 works out to 57 meters that we've traveled. Next problem. Actually, now we're on a we're at an explanation of the average velocity. So very similar to the average speed, the difference here is that instead of the difference in the distance traveled, it is the displacement. So the total displacement divided by the time. So let's look at an average velocity question. This question says, on a windy day, a balloon's position changes as it is blown 82 meters north away from a child in 15 seconds. What is the average velocity? So here, my v with an arrow on top, because now I'm looking at average velocity, is the displacement with an arrow on top over the time. This is 82 north divided by 15 seconds, and using our calculator, 82 divided by 15 gets us to 5.5 meters per second, and the direction is north. Another question. A subway train travels at an average velocity of 22.3 kilometers per hour west. So now we're using a different unit than meters per second. It says, how long will it take for the train to undergo a displacement of 241 meters west? So this will involve us having to do some conversions. Okay, so let's look at this. The first thing we need to do for this question 4, we need to solve for time. And time is equal to that displacement over the velocity, the average velocity. But our average velocity is in kilometers per hour. So what we're going to need to do, I'm going to write this in my denominator. My velocity in kilometers per hour has to be converted to meters. So to change kilometers to meters, we multiply by 1,000 meters. And to change hours to seconds, we multiply by the amount of seconds in an hour, which is 60 seconds in a minute times 60 minutes in an hour. So 60 times 60, that's the equation we have to, or that's the conversion factor we have to multiply that by. So let's do this all together here. We have a 241 meter west displacement, and we have a 22.3 kilometers per hour times 1,000 meters over 3,600 seconds. That is directed west. And let's put this in the calculator. I'll leave this off to the side so we can see our calculator well. So in this case, we have 241 divided by, I'm going to hit the bracket button, 22.3 multiplied by 1,000 divided by 3600. I'm going to close the bracket because that's my denominator. If you have a calculator like this, it might show you a value. That's just showing you the value of the denominator. If I hit equals, I'll find out the value of the time. And I end up with 38.9 seconds. So if you come across a kilometers per hour measurement and you need to convert it to meters per second, you multiply by 1,000 and divide by 3,600, which is equal to 60 seconds in a minute, 60 minutes in an hour. And we'll leave it at that for this lecture.